So number 11 then, part A. So we've got to find the gradient then of the line L2. So what I'll do is I'll just write the line L2 out, so it's 3x plus 2y minus 8 equals 0. Now just to remind you, first of all, you should remember that any line can be put in the form y equals mx plus c. And you may remember that m is the gradient and c is the y-intercept. Now in this question we're asked for the gradient, so if I rearrange this equation into the form y equals mx plus c, I should be able to just read off the gradient. So in order to do that, I need to first of all subtract 3x from both sides and also add 8 to both sides. So therefore I'm going to get 2y equals negative 3x then plus the 8. Next I want to divide by 2 to both sides, so we have 2y divided by 2 is y, and then next I could put the whole lot here over 2, but because I want it in this format with two terms, I think what I'll do is I'll just write minus 3 over 2 x, and then 8 over 2 is obviously 4. So now that we've got it in this form, we can see straight away that the gradient m is negative 3 over 2. So therefore the gradient of the line L2, okay, equals minus 3 over 2. So, hope you got that one. Now we move on to part B. And in part B we've got to find the coordinates P where the lines L1 and L2 intersect. And if you're finding the point of intersection of two lines, for instance in this case, it will be simultaneous equations. In fact, if you're finding the intersection of any two graphs, you would always find that point of intersection by doing simultaneous equations. Okay, so let's write down those equations. First of all, the one for line 1 was y equals 3x plus 2, and the other line was 3x plus 2y minus 8 equals 0. And with all simultaneous equations, it's good to get into the habit of numbering your equations so that we can identify them through the stages that we do. Okay, so to do this type of simultaneous equation, the easiest method is immediately to use substitution, because I've got y in terms of x here, and I can substitute this into equation 2. So rather than just doing it, make sure you try and introduce what you're doing so that the examiners or anybody reading it can follow what you're doing. So what I'm going to say is sub equation 1, okay, into 2. So therefore what I get is the 3x plus 2 times y, but y we know is 3x plus 2, so we'll put that in brackets, 3x plus 2, and then we have minus 8 equals 0. So if we expand this, we get 3x plus 2 lots 3x, well that's 6x, and 2 2's are 4, minus the 8 equals 0. Simplify this, we have 3x plus 6x is 9x, and 4 take away 8 is negative 4, so we have that equaling 0. Add 4 to both sides, and we have 9x equals 4, and then divide both sides by 9, and that leaves x equals 4/9. Okay, so we've got the x coordinate of the point of intersection it asks for the coordinates of P, so we need the y coordinate. So it seems sensible to substitute this value x equals 4/9 into the equation 1 because it will give us y directly. So therefore what I'm going to do is say therefore sub x equals 4/9 into 1. Okay, it's a good idea to write something like this again just to show the reader what you're doing rather than just doing it and getting them to try and figure out what you're doing. So if we sub x equals 4/9 into 1, we therefore have y equals 3 times the 4/9, okay, plus 2. Okay, so I could either say 3 times 4 is 12 over 9, or I could even just cancel this. 3 into 3 goes once, and 3 into 9 goes 3 times. So what I have here is 4/3, and we have 4/3 plus 2 whole ones. 2 whole ones is 6/3, so 4/3 and 6/3 is 10/3. So therefore at this stage I have got the point of intersection P, so I can say that therefore P has a point of intersection of 4/9 and 10/3. So they're the coordinates of the point of intersection. Right, well I hope you got that bit. So we now move on to part C.